Acha, 4 operations on complex numbers. Now, the addition and subtraction of complex numbers is not different or not difficult. It is just like algebraic addition or subtraction. For example, you have a complex number which is 2 plus 3 iota. You want to add this with another number which is 5 plus 2 iota. Okay, this is just like if you have, for example, if you have 2a plus 3b and then you have 5a plus 2b. So as you add the like terms in algebra, like this 2a will be added with the 5a, so you have 7a, and 3b will be added with the 2b, so that is going to be 5b. So the real part is added with the real part, and the imaginary part is added with the imaginary part. Like if you, for a moment, if you just ignore that, just forget that these are complex numbers, and let's say these are two algebraic expressions, which is 2 plus 3i and then plus 5 plus 2i. We know that this 2 will be added with the 5 and 3i will be added with the 2i. Okay, so that is going to be 7 plus 5 iota. Okay, similarly, if you have, let's say you have 3 into 5 minus 4 iota minus 2 into 6 minus 3 iota. Okay, so this is exactly the same as you have been doing in your algebra. So this is going to be 15 minus 12 iota minus 12 plus 6 iota. Okay, and this is going to be 3 minus 6 iota. Okay, so I'm not going to go into more examples for this addition and subtraction, but I would be doing more examples on multiplication and division. Now, you people remember that, like, this is something optional that I'm just going to do with you people, that a plus b whole square was a square plus 2ab, and then this was plus b square. And we also wrote it like a square plus b square plus 2ab. Imagine you have, instead of this a plus b, now you have a plus iota b whole square. Guess what will be the square of a plus iota b? Yeah, but when you, like, if I expand it here, this is a plus iota b whole square. So this is going to be a square plus 2a into iota b plus iota b square. So this is a square plus 2ab iota, and then this is plus iota square b square. And we know that iota square is minus 1. This is a square plus 2ab iota minus b square. Now, the terms that don't have an iota with them, they are a part of the real part, okay? So this is a square minus b square plus 2ab iota. Now, this much is the real part of this a plus iota b whole square. And this is the imaginary part over here, okay? So this is an optional thing for you. This can really save your time when you're dealing with the longer questions. If you remember that a plus iota b square is going to be a square minus b square plus 2ab iota. Guess what would be a minus iota b whole square? Without any expansion, can you tell me what is a minus iota b whole square? A square minus b square minus 2ab iota. Because beta, this is the 2ab term. If you have a plus here, there is a plus over here. If it is minus here, this is going to be minus. Okay. So this real part is going to be the same because of this a square plus b square thing. So, but this part where you have 2ab, that will have a different sign over here. Okay. Now guess. We have to guess that without any working. Like, you people know that what is a plus b into a minus b. You know that is a square minus b square. Now guess, what if you have a plus iota b into a minus iota b? A plus iota b into a minus iota b. A square plus b square. Very good. This is a square plus b square. Now let me explain why it is a square plus b square. This is basically, this is still a square minus iota b square. Okay. But when you simplify this, you get that a square minus iota square b square. And you know that iota square is -1. So this minus into minus will make it plus. So now you people should be feeling a little bit satisfied that you have always been saying, hi, R, if there is a difference of the signs, we can factorize it like this, a plus iota b and a minus iota b. But if there is the same sign, we cannot simplify this. We cannot factorize this. But now you have learned to know we can still factorize this. So this can be written as a plus iota b into a minus iota b. Okay? So now let's try some questions on the multiplication of these complex numbers. Let me pause there. Okay, now 4 part 8 is a 1 plus 3 iota into 2 minus iota. So this is the simple expansion. 1 into 2 will give you 2. 1 into minus iota will give you minus iota. Then 3 iota into 2 is going to be 6 iota. And 3 iota into minus iota is minus 3 iota square. Okay. So this is 2 plus 5 iota plus 3. So that is going to be 5 plus 5 iota. Whenever you're simplifying, I mean, a product or a division or a sum, your answer should always be in this form, a plus iota b. The real part and the imaginary part separated, okay? Now, can you explain, I mean, find this b part. This is 4 minus 5 iota into 4 plus 5 iota. If you write this directly as 16 plus 25, this is going to save a lot of time when you will be doing the division of these these complex numbers. Look at this part C. It is 7 minus 3 iota square. Okay. If you simply expand it like this is 7 square minus 2 into 7 into 3 iota, and then we have plus 3 iota square. Like you have simply the previous formula, a square minus 2ab plus b square. Okay, so then you have, this is going to be 49. This is 2 sevens are 14, 3s are 42, 42 iota, and this one is plus 9 iota square. Okay, so now you have 49 minus 9 minus 42 iota. So that is 40 minus 42 iota. Got it, Pacho? Similarly, I have here, now let's do this one. Now suppose you have 2 plus iota raised to power 5. You want to expand this. How many of you remember your binomial expansion, binomial theorem? Yeah, so let's do it through the binomial expansion. So this is 5c0, 2 raised to power 5, iota raised to power 0. 5c1, 2 raised to power 4, iota raised to power 1. 5c2, 2 raised to power 3, iota raised to power 2. 5c3, 2 raised to power 2, iota raised to power 3, plus 5c4. This 5 should be written a bit higher. Okay, this is 5c4, and then you have 2 raised to power 1, iota raised to power 4, and then you have 5c5, 2 raised to power 0, and this is iota raised to power 5. So this is your binomial expansion. Do you remember this, Pacho? Yes? Okay. So now, let's do one more step here. Now this is 5c0 is 1 into 32 into 1 plus 5c1 is 5 into 16 into iota. 5c2 is 10. So this is 10 times 8 times iota square. Then you have 5c3, I think there is 10 as well. This is 10 into 4 into iota cube. Then if 5c4 is 5, please confirm from your calculators. And this is iota raised to 4. 5c5 is 1 into iota raised to power pi. Okay? Now, finally, this is going to be, this is 32, this is 80 iota, 80 iota square. What is iota square? 1. Okay, I'm just writing this 80 down here. So 10 into 8 into iota square is simply 80. Okay, 10 into 4, that is 40, and iota cube is, oh, iota square is minus. Oh, sorry. Iota square is minus. So I had to write minus here instead. Okay, so iota square is minus 1, and then iota cube is minus iota. Okay, this is minus 40 iota, and iota is for 4 is basically 1. This is 10, so I'm just writing down here plus 10, and then iota is for 5 is going to be simply iota. Okay, so this is minus 38. देखना यार, minus 38 and plus 41 iota. So that is, you see that all of this has to be written finally in this form, a plus iota b. There should not be any iota square or iota cube, okay? So one real part and one imaginary part, okay? Now you please try this, this D part, 4D, which says this is 3 minus iota raised to power 4. You expand this fully and tell me what is your answer. So if you simplify this, expand this, you must get this 28 minus 96 iota. Okay, I'll be discussing the division in the next class.